Okay, guys, last three response problems I'm going to do today, and I'll give you two for homework, and we will have done everything since 2008 that's applicable to this year's test. So let's get into it. The rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. There's a lot of words there. The time t equals 0 when the bird is first weighed, its weight is 20 grams. They kind of say the same thing down there. B0 is 20. BT is the weight of the bird, so that's the weight of the bird, in grams at time t days when it's first weighed then. Okay, so guys, up here they said the weight of the baby, the rate at which it gains weight is proportional between its adult weight, so 100 must be its adult weight and its current weight. So look, this is essentially dB over dt equals some constant times b. So the rate of change is proportional to the current weight, essentially. Okay, so I just wanted to show you that's what they're saying. So y equals bt is the solution to the differential equation above with that initial condition. All right, we did this. This is a proportional problem. It was one of the later sections that we did this year, just before the shutdown. So when something is proportional to the rate of change is proportional to the current amount. Classic radioactive decay problem or exponential growth. All right, so that's the basics of it. You gotta. This is the thought process you got to go through when you're solving these problems. There's a lot of information here, but basically, the rate of change of the bird's weight with respect to time is proportional to the difference between its adult weight and its current weight. All right, so they're asking part A. Is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? So gaining weight faster, what tells me the rate at which it gains weight? Well, that's dB over dt. So guys, all it's asking is who has the bigger dB over dt. That's a pretty easy problem, okay? So I come down here A. So I evaluate dB over dt when B equals 40. That's 40 grams. That is just 1/5 times 100 minus 40. So that's 1/5 times 60. So that's 12. And then I'm going to evaluate dB over dt when B equals, what's the other number? 70. So that's just 1/5, 100 minus 70. And this is in the non-calculator section, so they expected you could do all this without a calculator. So it's 6. So since dB over dt, when B equals 40 is greater than dB over dt when B equals 70, the bird is gaining weight faster when it weighs 40 grams. Okay, answer the question, guys. So I'm looking, they give you 1 point for doing this, they give you 1 point for doing that. All right? All right, let's see part B. Okay. Find the second derivative of B with respect to time in terms of B, and use it to explain why the graph of B can't look like this. So this is the graph. This is a graph of B of t. That's the graph. Okay. So first thing it asks me to do is find the second derivative of B. So B, I got to find the second derivative of B with respect to time. Okay. So that's dB over dt there. If it helps, dB over dt equals, what's 100 divided by 5? 20 minus 1/5 b. Okay, so the second derivative of that is just negative 1/5 dB dt, right? The derivative of a constant 0, the derivative of b is dB over dt. So that's just negative 1/5. What's dB over dt? 1/5 times 100 minus b. So guys, that is negative 1/25, 100 minus b. All right, guys, let's see. B, the baby bird. The bird starts at 20 grams. Its full weight is 100, an adult. So since B is between 20 and 100, the second derivative of B with respect to time is always, almost wrote the wrong direction there. It's always less than 0. Less than 0. Therefore, BT is concave down from 0 is less than or equal to t, less than or equal to, how long is this thing? 100. I'm sorry, not 100. It just concave down for the bird's entire life. The given curve is not concave down the entire way. So it can't be it. Okay? Guys, look over, they give you 2 more points for that. Okay, 1 point to find the second derivative, 1 point to say, talk about the concavity. All right? Part C. Use separation of variables. It's nice. They tell you what you have to do. Use separation of variables to find y equals b of t with the initial condition b of 0 equals 20. So guys, I know this. Part C. Always good to label your stuff. Help the grader. You tend not to want to piss the grader off. So equals 1/5, 100 minus b. Guys, I did it up above. It's 20 minus 1/5 b. Okay, so I'm going to do, I'm going to do separation of variables. Okay, I'm going to break the pencil first. I'm going to do that first. And then the pencil's not going to work for you anymore because it didn't like the fact that you broke it. It's okay. Happens. All right. So I'm going to do separation of variables. This has b in it, so I'm going to move it to the other side. db over 100 minus b equals 1/5 dt. Okay? Let's see. There you go. Okay. So guys, please do use substitution. Okay? I know you can't do this in your head, so do use substitution. I'm going to integrate both sides. Okay? So I'm going to make u equal to 100 minus b. So du is going to be negative db. Okay? So now, given that, I'm going to get negative du over u. Again, db is negative du, where u equals negative db. So db is negative du. That's where that comes from. This is u equals integral of 1/5 dt. Take the integral. Remember, this is a special case when you got u to the minus first power. The integral of that's natural log. So you get negative natural log of u equals 1/5 t plus c. Okay? Substitute back in, negative natural log of 100 minus b equals 1/5 t plus c. Guys, you're going to need the absolute value because this is always positive, okay? It's always positive, so I don't really have to worry about it. So at any rate, I'm going to solve for the initial condition. I know b of 0 equals 20, okay? So the negative natural log of 100 minus 20 equals 1/5 times 0 plus c. So that tells me c equals the negative natural log of 80. That's c. Guys, I'm looking over the solution. I am up to 3 out of 5 points. Okay, so right now I've got this negative natural log of 100 minus b. I got rid of the absolute value because I told you this is always positive, equals 1/5 t minus the natural log of 80. Okay, so now I want to get b all by itself, and this is going to be the last point. I'm up to 4 points right now, 4 and 5. This is the last point, so I'm going to raise both sides to the exponential power. So I'm going to get, let's see, what do I want to do here? I'm going to get, actually guys, you know what? I'm going to divide by -1 first. So natural log of 100 minus b equals -1/2 t plus the natural log of 80. So that 100 minus b equals e to the -1/2 t plus the natural log of 80, which happens to equal e to the -1/2 t times e to the natural log of 80. Remember your exponential stuff, this is just 80. So I get 100 minus b equals 80 times e to the -1/2 t. Okay, so if I rearrange to get b by itself, I get b of t equals 100 minus 80 e to the -1/2 t. That's the answer. Let me check. They got the same thing they did. That's the whole problem.